Uh, Good afternoon, ladies and gentlemen. So it's already 3. So we are starting with our webinar session. So I'm Aniket from EDS Technologies and I will be your host for today's webinar. So first of all, we thanks each and everyone for taking out the time and joining the webinar, Empowering Tomorrow's Engineer, FPGA Innovation with Synopsys. So now I would like to introduce Mr. Tharun. He has more than 8 years of experience in EDA tools and services, and he is the brand manager at EDS Technologies. And he will be giving a short brief about EDS Technologies corporate profile. So over to you, Tarun.
Okay, so good afternoon, professors. I'm myself Tarun. I work as a brand manager for Synopsys product lines in EDS Technologies. The agenda of this webinar is to give an introduction of Synopsys FPGA tool flow. So I have with me Mr. Nilesh, who is from Synopsys. So I'll give the background of Mr. Nilesh shortly. So now I will take you through the introduction of our company, EDS Technologies. So EDS Technologies is a 30 plus year old company in the market, which provides multiple diversified engineering solutions for different engineering verticals. Having headquartered in Bangalore, we have offices in Coimbatore, Chennai, Hyderabad, Kolkata, Mumbai, Pune, Ahmedabad, Gurgaon, and Noida. So we have, as I said, like we have diversified engineering solutions. So we are primarily we are a platinum partners for Dassault Systems in India for the PLM solutions, and we are partnered with ISRI, which is mainly on the GIS solutions, and Technia, and EOS, which is the 3D printing company. We are partnered with Synopsys, as you all aware, and so regarding that, the solutions will be discussed later. And Mac Technologies is mainly for the visual simulations and humanities. So we are partnered with all these OEMs, and today the session will be focused mainly on the Synopsys solutions. So we are a trusted partner for more than 2,000 customers in India with respect to multiple engineering disciplines like automotive, aerospace, defense, industry, mining, etc. Okay, and we have a dedicated regional sales team sitting in the multiple locations, and we have strategic alliances with the global leaders who are all pioneers in their respective technologies. And primarily, we are an end-to-end technology solutions provider in the country. So now, coming to the Synopsys and EDS partnership. So Synopsys, as you know, many people I think you are aware about Synopsys, but still I would like to give an introduction about Synopsys. So Synopsys is a valued partner for the global silicon to systems design across a wide range of vertical markets, empowering technology innovators everywhere with the industry's most comprehensive and trusted solutions. So Synopsys is a leading EDA company globally, and it's a $6 billion company. It's a very big company, and they have solutions for the advanced electronic system design solutions. And EDS Technologies is the valued partner for Synopsys in India, and our primary focus will be to provide end-to-end solutions for the customers for these product lines, mainly the electronic design for automation EDA tools, Synopsys optical solution tools, virtual prototyping solutions for the automotive industry, and Synopsys Center of Excellence with academia, which is mainly for this particular, the main agenda of this session is to focus on the Synopsys Center of Excellence solutions. Okay, so this partnership with Synopsys, especially for the Synopsys Center of Excellence, will be a value add to the engineering colleges in India, especially with the electronics and communication engineering discipline, to set up their VLSA labs and to set up their center of excellence, which is mainly to bridge the gap between the industry and the academia. So which is a very big challenge nowadays that most of the institutions are facing. So we have solutions to address that. So I just wanted to give you an overview, like what government of India is doing with respect to this semiconductor technology in India. Like now we see that semiconductor is being a buzzword each and every day. When you open LinkedIn, we see a lot of initiatives that the union government is proposing. So if you see a grant of 76,000 crores is being allocated to make India as a self-sustainable semiconductor ecosystem. So this transformation, you would be noticing it after COVID, because there was a huge semiconductor shortage across the industry. So India found its potential that it is going to come a big way in the semiconductor industry. So from 2020, there has been a very serious activities that is happening in the Indian semiconductor industry. So the government is planning to come a big way, and it is anticipating that at least 200,000 to 300,000 engineers to be employed by 2027. So that is the target that is being set. So which I hope this information would be an eye opener for most of the colleges to guide your students to change their perspective, see how the semiconductor industry works, and how what are all the opportunities that they have through these programs. So the government is keenly looking to set up semiconductor fabrication units in India, display fabs, compound semiconductors, silicon photonics, sensor fab, discrete semiconductor fab, ATMP and OSAT facilities. And the government has also proposed some incentive plans for the startups to make India a self-sustainable semiconductor hub of the globe. Okay, so now I'll introduce Mr. Nilesh. Mr. Nilesh Shilankar is a staff application engineer at Synopsys International Corporation. He sits in India office, Bangalore. So Nilesh works as a staff application engineer, and his expertise is in FPGA-based prototyping and implementation. And he currently works for the global support team at Synopsys Bangalore, and he front-ends the FPGA team with the customers globally. He's from CDAC. He's a bachelor's in electronics and communications engineering. So now over to you, Shilankar. I hope the audience will have a great takeaways from this webinar. Thank you.
So first of all, I would like to say thank you to Tarun and Aniket for organizing this webinar. And I also would like to thank you, EDS Technologies, for organizing this webinar. So, and also I would like to warm welcome to all the participants to this webinar. Okay. So today I'm going to talk about like Synopsys FPGA platform enabling faster design verification and debug of FPGAs. I will also talk on like what are the current trends in the FPGA markets, what are the current trends in the EDA industries, okay, what are the current challenges that today the FPGA engineers are facing, and Synopsys being the EDA leader in the FPGA synthesis, what solution we are providing to address these challenges. So here is the agenda for my talks today. Okay, so I will start with like what are the applications of FPGAs where FPGA has been extensively used. I will also talk on like how the FPGA technology has been evolved over the years. Okay. And I will also talk on like what are the current trends in the FPGA technologies, what are the emerging technologies and their impact on the FPGA, means which are the areas which will make or which will decide or which will impact the future of the FPGAs. what are the challenges for design and verification of FPGAs, and what are the innovation and developments are happening in the FPGA industries, and what are the solutions Synopsys offers for this FPGA based design and debug. So FPGA offers like lot of advantages that makes them like adapt to various industries. They have a like flexibility to reprogram multiple times, and another thing, another advantage they have is like they can do a parallel processing. FPGA consists of like lot of logical blocks and interconnect, which will make them like to use into for using for high-speed applications. Okay, if I talk in terms of like automotive, FPGA can be used for your infotainment system, then your ADAS system, for your driverless car driving system, and also it can be used for your engine control units to control your engine. Okay, it can be used in telecommunication sector for your baseband beam transmissions. It can be used in routers. Apart from this, it can be used in terms of government and aerospace sectors, aerospace and defense sectors, where you can use FPGAs for your avionics and military communications. So these are the different industries or areas where FPGA is like extensively used. Nowadays, FPGA can be used in data centers for your AI accelerators, and it can be used for your financial services as well. So let's look at like what are the different FPGA vendors available in the market. So there are different FPGA vendors, FPGA manufacturers available in the market. AMD is there, which is Xilinx. Okay, Intel is there, Microchip, Lattice, Acronix, FlexLogix. So these are the big players which are available in the market. But apart from this, there are different vendors also available. So I will try to focus on this AMD Xilinx FPGA, and we'll also look at like how this FPGA has been evolved over the years. So this picture I took from AMD. So here we can see like how the FPGA has been evolved over the years. So FPGA are keep evolving over the years in terms of its capacity and the process technology. These are not only the things which are like keeps evolving, but there are other things also which keeps evolving over the years. And now we can see like what big kind of FPGAs are available. So here you can see like the Vertex FPGAs, which was launched in like 2006. At that time, it was consist of around 3030 transistors, logic elements at that time. Okay, over the years, it has evolved, and it has become like Vertex 6, Vertex 7, Vertex Ultra Scale, and Vertex Ultra Scale Plus till 2019. And in 2023, they launched the device which is called as like Versal, which is the biggest device available in the FPGA market. And this Versal device is manufactured on the process technology of 7 nanometer, and it consists of like up to 60 billion logic gates. Now let's look at like what are the current trends in the market or FPGA. So initially FPGA were like designed to be used as a standalone devices, but over the years it has like evolved a lot that it cannot be used as a simple FPGAs, right? So it has like introduced lot of peripheral devices, processors, and AI engines to accelerate your design and development. It has also evolved in terms of its interconnects and network. The main idea behind is this is like we should be able to fit lot many logic into the FPGA, and FPGA should be your more independent to take decision and to act according to the real-time data processing. So I can see in the pictures like FPGAs are like becoming now very big and very large in size. So previously, if we want to connect it to outside world, like if I take the example of like USB or maybe like a MIPI, okay. So you have to write everything like from scratch in the FPGA, and that used to consume your FPGA logics. But now we are like putting all the hard IPs into your FPGAs, so that the data communication will be taken care with that IP, and your FPGAs will become more independent to do other activities, to work on the to work it parallelly. At the same time, uh, we are like creating the fully integrated environment to deal with these FPGAs. And as I said, like no one is like writing the codes from scratch nowadays. So we are like integrating a lot of IPs, and we also need like some proven IP track record which is available in the market. So we have seen like what are the applications of FPGA and what is the current trend in the FPGAs. So now let's look at like what are the emerging technologies and their impact of FPGAs. So I have find out some of the key areas where FPGA will be having a very big impact. So one of them is like a 5G technology. 5G technology is nothing but your uh, wireless communication standard, next generation wireless communication standard, which demands very high speed and very low latency. So as you know, like everyone is like now in, at least in India, we are using 5G technology. But outside of this, in our country, many of the countries are like already using 6G and 7G technologies. So this is like one of the growing area or emerging technology where FPGA has been extensively used. So being an reprogrammable capability for your FPGAs, and to be working at very high speed, FPGA will be the best suited for developing our 5G technologies. Next thing is your AI/ML algorithms. As you know, like AI and algorithms demands like a lot of uh, computation. They requires a lot of computational power, right? And with this advancement, like FPGA should be able to handle it. Okay. If you look at in terms of like AI and algorithm, they need to process a lot of data to be at parallel. So FPGA will be the best suited for this AI and ML algorithms and their implementations. Next thing that will also impact and will also affect the future of the FPGA is the quantum computing. So you know, like quantum computing is the next state where we will be developing all the quantum algorithms, where it is very fast, and we will be needing some platform to deal with this fast computing, and where our normal or commercial computers will not be able to deal. So how FPGA can be helpful in quantum computing is like FPGA can provide a platform to prototype any FPGA, any quantum algorithm. At the same time, FPGA can be used to do a quantum simulation or quantum emulation to prototype any of your quantum computing. Quantum computers, like development of quantum computer is at like very early stage. At this is the very early stage for this quantum computing, but FPGA can be extensively used to prototype and to evaluate the quantum computing applications. Now let's look at like what are the innovations and developments are happening into the FPGAs. So in terms of architecture, FPGA architecture like keeps evolving. Okay, there could be like three areas where the innovation and developments are keep happening. Okay, one is like at your FPGA architecture. Another is like the EDA software that we use to use your FPGA architecture, and then the methodologies in your FPGA designs. Okay, so we'll just see like how this the innovations are happening into the FPGA industries as well as the EDA industries. So in terms of architecture, FPGA keeps on evolving, right? And previously, as we seen, right, the FPGA were used only for like the standalone devices, but now it is not that case. Now we are trying to integrate other technologies into the FPGA to make it more heterogeneous. Okay, and we want this hybrid architecture to be available so that it can have the capabilities of like ASIC as well as your reprogrammable FPGAs. And we are also trying to implement the hardcore IPs into your FPGAs. And at the same time, we are day by day like evolving new technologies where we can have a very good architecture or very innovative architecture for your FPGA development. So the FPGA manufacturer has already answered to this requirement by making this heterogeneous architecture for your FPGAs. And at the same time, they are also trying to increase the speed of your clock. Okay, and like they are trying to build more capacity FPGAs. Okay, in terms of EDA tools, their EDA tools are also like evolving, and they are like tightly integrated to be matched with the FPGA architectures. So one of the key advantage that EDA tools are like evolving is like your HLS, that is your high level synthesis. So what this HLS will do, it will try to give a platform so you can write a code at C level language, and the tool will automatically convert that code into your FPGA understandable format. Okay, so this EDA tool has been like putting a lot of investment and lot of putting into investment into your R&D to develop a tool so that the engineer should be able to write at their own convenience, and they should also able to enjoy the technology, the high-speed technologies which is provided by your FPGAs. Apart from that, we are also looking at the methodologies for your FPGA-based designs. Okay, so we are looking at like how we can manufacture the FPGA as well as the EDA tools which will help you to do the parallel processing. Okay, so we are introducing the pipeline into our design. We are looking at like how we can break down the design, and we should be able to run it parallelly. At the same time, the EDA industry is also looking at like how we can generate the optimized results. So let's look at like what are the current challenges to be available into the FPGA design and verification. We'll just look at like for each of these points which I have mentioned here. Okay, as you know, like the design complexity is like increasing. We need the tools or maybe the EDA industries to provide a good quality of results. Okay, so so that the designer should be rely on these EDA tools. Okay. At the same time, as the complexity is increasing, uh, they want the debug analysis and visibility to be available to the designers. Means for this complex design, if you're writing any codes or any IPs you're using, you should be able to debug and analyze your results very quickly and efficiently. And at the same time, before going for your actual hardware debug, we should be able to do the gate level as well as the RTL simulation to your design. At the same time, as I said already, that no designers will write their design from scratch nowadays. So they want a proven IP track record should be available. Some standard IP protocol assurance should be available to them. Okay. If they want to move from one technology to another technologies, we should be able to support the encryption. Okay, and the tools, the EDA tools which are available in the market, they should be able to support the broad language support. As we know, right, we use VSDL very long, and that languages keeps evolving every time, right? our tool should be able to handle that constraints or that constructs, and we should be able to support that broad language. At the same time, if you are using your FPGA in a very critical state, okay, so we want to make sure like whatever the design is implemented in your FPGA, it should be reliable, okay, and to be standardized, it should be we should have some standard for traceability, okay. So the tool required for this kind of handling situation should be should this high reliability design should be available, okay, and the tool should have a standard reporting structure. The logs file which is generated from the EDA tools should be standard across all the formats, so that it will help to get some industry standard authorizations, okay. And the tool should have a repeatability of results, right? If you have generated some results maybe like 10 years back, and today also if you are like checking the same design with the same version of the tool, the tool should be able to produce the same results. At the same time, the expectation or challenges what we have for the FPGA based design and from the EDA industry is like we should support for like faster design setup. Means like if you want to check something or maybe if you want to prototype something, so that design should be able to faster setup on your FPGAs. And we should have a technology in your EDA industries, so that we have to look like in how less iterations I should be able to fix my bugs, okay. And with very less iterations I should get good quality of results, and I should be able to find and fix my bugs as soon as possible. So by looking at all these challenges or maybe the growing complexities, so we can see like as ASIC is there, so FPGA designer also needs ASIC like design methodologies for their design development and debug. So now let's look at like the two use cases of FPGA. So till now we have seen like what are the applications of FPGAs, then what are the current trends in your FPGAs, and like what are the innovations are happening at the FPGA architecture level as well as the EDA industries, and we have seen like what are the challenges, okay. So now let's look at like what are the two use models for FPGAs. So FPGA can be used for either like doing a prototyping, or it can be used to do a implementation, okay. That means implementation means like your end application or your end product uses your FPGAs, okay. So when we are saying like we are doing prototyping, that will help to migrate your ASIC designs to be validated on your FPGAs, okay. That is called as like ASIC prototyping. So this will help for your like early access of your software development, and it will also help for your hardware and software integration and validation, okay. To address these prototyping challenges, Synopsys offer a HAP solution. HAP solution is a hardware high-speed ASIC prototyping system, okay. And to deal with this HAP system, we have a software called as like protocompiler. And if you want to use FPGA as your end application for implementation, we have a software called as like Simplify. We'll see more details about Simplify in the next slides. But before going to that, let's see like what is our traditional FPGA design flow. Okay, so as everyone know, like the traditional FPGA design flow consists of your design entry where you will write all your RTLs or you will use your IPs. Okay, and next step is you will be doing like behavioral simulation, okay, for your functional verification. Next thing you are doing synthesis like you will convert your RTL to get level netlist. At the same time, we will do the debug insertion, which will help us to debug your hardware or RTL when your FPGA is running. Okay, after that we'll do the place and route, and after that we'll do the board debug. And as you see, this all the steps will be like interconnected or will help you to go back and do the iterations. Okay, So we need a tool sets which will be helpful at each level of the at each step. Okay. So to address these challenges and looking at this flow, Synopsys has a comprehensive set of tools which can form a complete platform for your FPGA-based design, planning, verification till your hardware debug. So this is the comprehensive platform Synopsys offers. Okay, the main thing which sits in between is your Simplify. Simplify is your synthesis tools. Okay, and it has a tight integration with your Spyglass. Okay, which will help you to do static lint CDC checks. Okay, the Simplify will only generate the scripts which is required for your Spyglass. And if you want to do simulation like your RTL simulation or like gate level simulation, you can use the VCS. Okay, VCS is again an industry standard tool which is available in the market for doing your simulations. Okay, and another thing is like your Identify debugger. Identify debugger will come with Simplify Elite as a standalone tool which will help you to debug your hardware. And this is also tightly integrated with Verdi to do your waveform analysis and all. So Simplify will come with 3 variants: Simplify Base, Simplify Elite for your advanced synthesis, and Simplify Apex, which consists of your unified compiler as a front end. So that means in Simplify Apex, your front end compiler will be VCS. So now let's look at this complete platform, like how it will help. And in Simplify, like what are the techniques available which will make it very much beneficial as compared to others, right? So first thing is like it has a broad platform. Means multi-vendor support is available. Okay. So in Simplify, it's a synthesis software. It will generate a netlist first, which is like technology independent. And based on that, your requirement, you can map that independent netlist to any of your vendor, which is of your interest. Okay. So this is the biggest advantage of the Simplify. Apart from that, it will also help you to faster your design setup. In terms of like it has like broad language support is available, and it has like IP handling and constraint setup facilities are available in Simplify. And then to quickly go to your market with your product, we need to check the functionality. So we support some of the features like continue on error and fast synthesis and constraint checking, so that you can quickly generate your constraint, you can validate it, and you can get the bit file to test it on your FPGAs. Okay. If you want to debug your system, we do provide the facility like in system debug and the incremental reroute. So this made it like very much faster to debug your system. At the same time, Simplify, we also have some of the feature like advanced synthesis and exploratory part to give you the best and high performance result for your FPGA based implement. We'll see like about the Simplify. So Simplify being the industry leader for your FPGA based synthesis for more than 25 plus year is already available in the market. And it has like the synthesis engine, which is like supports multiple vendors in your for your FPGAs. Okay, means same netlist which you have generated, or maybe same RTLs that you have used in your Simplify project, that can be tested on like multiple FPGA vendors to test the functionality, to check the availability of your IPs, and to check the results or to check the quality of results, QOR. Okay. We do support the advanced synthesis strategies to get you the high performance and optimized area results. Okay, and it also has broad language support. That means all the latest constructs is supported by the Simplify. And you can use the advanced synthesis strategy as well as the routability strategy as well as the base strategy to check the functionality. Based on your requirement, you can check the synthesis strategy and you can check the results. Okay. It also has like some of the safety and mission critical design automations are available, where if you want, like if your FPGA is like being used in a very critical situation where the single event transient can happen, to protect your design, we do provide the automation for creation of your like reliable designs, at the same time your functional safety designs. Okay, so in this, what exactly we do is like we have this, we try to replicate your logic to make it separate, and we will put it at the voter logic, so that if any event happen or any of your design get corrupted, the voter logic will see the maximum of 3, and you will get the corrected result. At the same time, it also support for your safe case FSMs. That means if any unwanted state comes, uh, the tool will try to make your design back to your reset state. Okay, and to faster your board bring up and debug turnaround, we do have a tight integration with identify debugger as well as the wordy. Okay, to view your waveform at the RTL level itself. This is the very big advantage that we have. That means once you have programmed your device, and if you are running, if your code is running at your FPGAs, so you can trace back the values, and you can check it instead of your waveform, you can check the RTL values at the RTL level itself, or the signal values at the RTL level itself. Okay, and so this Simplify is like the industry standard tool which is available into the market, where mostly like more than 500 or 600 customers are like globally using it. Now let's look at like how this high reliable design or this high reliability feature is available in Simplify. Okay, so to protect your to protect your FSMs, or it supports the safe FSM as well as safe case FSM, and at the same time it supports having 3 error detection and recovery techniques to be available in your FPGA. So you don't have to do something extra logic for this, but the tool will automatically, once you enable it, the tool will automatically put that reliability in your design. Okay, to protect your logic and register, it supports the TMR. TMR is nothing but your like triple modular redundancy. So what exactly happens in TMR is like it will try to replicate your logic, and it will be combined through voter logic. So if any single event upset happens, it will try to mitigate that thing. Okay, and your design is not affected. For to protect memories, we also support TMR for your BRAMs, and we also support for like creating error flag. Okay, and we also support for like creating your ECC error correction codes for your RAM primitives. So that if any things or any corruption happens, it will raise your error flag, or maybe if there is any uncertainty is there, it will try to correct your it can detect the double bit error, but and it can also mitigate the single bit error. So this will help to protect your memories. To protect your global routing IO clocks, okay, we do support for like DWC, that is nothing but your duplicated with compare. So what happens is like we'll try to, instead of replicate, we'll try to duplicate the logic, and then we'll try to compare it. So if any uncertainty is there, it will raise the flag. Okay. So this is like a very much important feature is available in the Simplify, which is mostly used by your aerospace and defense customer. Now let's look at like what is my identified debugger. Okay, so identified debugger uh, is a is a is a hardware debug tool which comes with Simplify Elite. Okay, so it consists of two standalone tools, which is called as like identify instrumenter and identify debugger. Okay, so in identify instrumenter, what we do is like we'll try to mark up all the signals which are of our interest that we want to debug. Okay, or maybe we want to check the values. So during compilation, we'll try to set up this identify instrumental. Okay, there are different modes supported that we can set up. Okay, and at the same time, we can also set up like what is my sampling clock, or what are the signals that I wanted to generate the trigger. Okay, it automatically inserts the ICE. ICE is nothing here, in circuit emulator. Okay, which will probe and communicate to your logic. And at the same time, this identified debugger will support the mixed language designs. Okay, so once you instrument your design, then after doing synthesis and place and route, you can you can program your bit file into your FPGAs, right? Now the identified debugger will try to communicate with your FPGAs, or maybe the design running FPGAs, and it will help you to generate the triggers. So different trigger conditions are like can be possible. Okay, it can be like your simple trigger, it can be your complex counter trigger, or it can be your state machine triggers. Okay, so based on our setup, the triggers can be generated, and you can debug your RTL, and you can trace back the value at your RTL level only. As you can see here, like yellow it is marked. So you can trace back the values at your RTL, and you can check the signal values at your RTL. So you can either see the dump waveform into your RTL, or you can use that dump value to be forming the waveform, and you can validate in Verdi. At the same time, we support like generating or creating multiple ICE in your design to so that different clocks running at different frequencies can be help to generate the trigger for your each ICE. So we have seen like Simplify Elite being the industry standard software, which can be tightly integrated with all these tools. So that's why we are saying it's like a comprehensive tool sets we are providing to all the FPGA design and verification engineers. Okay, so it can be tightly integrated with your Spyglass to do a lean check. Okay, it can be integrated with your VCS for doing simulation, and the important part is like supporting the designware IP portfolio. So Synopsys being an IP company, it has like a lot of IPs available, which can be straight away can be consumed from your designware. So this IP portfolio is also can be accessed through your Simplify Elite. Okay. Apart from that, it has like identified debug insertion, and is a identified debugger is available. Okay. After that, you will do the place and route, which is again the vendor provided tool. Okay, FPGA manufacturer tool. Like if you want to do it for like Xilinx, then you can use Vivado for doing the place and route. If you want to do it for Intel FPGA, then you can use the Cortex for doing the FPGA place and route. After that, you will program your bit file in your board, and then you can use identified debugger, and then you can use the combination of like Verdi integrated waveform viewer with the Simplify. So this is the complete platform or comprehensive solution we provide for your FPGA based design and verifications. So as I said, like Simplify Elite provides a common anchorage to the whole platform flow, starting from your RTL generations till your hardware debug. Okay, and this augments the best industry technology to your FPGA. So Simplify is there for more than 25 plus available into the market, and it has like evolved a lot in terms of like getting you the best quality of results, the features. Okay, and it has like a proven track record in synthesis and verification. So yeah, with this, I would like to just conclude like what we have seen in today's presentation. Okay, we started with like what are the applications of FPGAs where the FPGA has been extensively used. Okay, then we have seen like how the FPGAs has been evolved over the years. Okay, then what are the current trends in the FPGA market? Okay, then what are like innovations and developments are happening, which are the emerging areas where the FPGA uh, FPGA future will be FPGA will tend to FPGA will try to develop the feature of this FPGAs. Okay, And we have also seen like what are the current challenges into the industries. Okay, and we have seen about how the comprehensive tool sets which is provided by the Synopsys, okay, and Simplify being the center of this excellence, and it can be tightly integrated with all the different tool sets which will help you to fasten your design and verification cycle. So with this, I would like to conclude, and if there are any questions, we can take it up. So Aniket, are there any questions?
Thank you, Nilesh. We still have
Yeah.
Tharun with the packages which we have available for the academia. So I would like to ask Tharun to please present those packages.
Aniket, hope you are able to see the screen, right?
Yes, we can see your screen.
Yeah. So thanks, Nilesh, for giving a brief and detailed explanation on the Synopsys FPGA solutions. Yeah, thank you, Nilesh. Now coming to the Synopsys Center of Excellence bundle. So I am just showing you the list of university bundles that is available. So we have from Synopsys, we have 6 bundles, which is the front-end bundle, back-end bundle, full custom university bundle, Sabre University bundle, which is mainly focused on the virtual prototyping, mainly for the power electronics design and physical design. And TCAD University bundle is mainly focused on semiconductor device design and manufacturing. And Asia Pacific Photonic IC bundle is mainly for the photonic IC design and simulation. So these are all the bundles that is COE bundles that is available from Synopsys. You can just make a note of it, and for inquiries we will share you the details for inquiry at the last. And now we can move forward to the Q&A session. I would request the participants to ask Nilesh your doubts so that everybody is beneficial from your questions. Thank you.
Okay, thank you, Nilesh. Thank you, Tharun. So we have our first question. So first question is, what are the job opportunities for FPGA engineers? If you could help us.
Yeah. So yeah, so so I will start with the manufacturing of your FPGAs. We have seen, right? So FPGA manufacturing, that jobs are mostly outside of your India. Okay, but in India, what mostly FPGA based jobs are available is like your FPGA based design and verification, where you will write the RTL, where you will be like generating the IPs. Okay, that can be extensively used in any of your FPGAs. Apart from that, we have something called as like verification of your IPs, okay, or verification of your RTL, how you can do the verification of your RTL, okay. Apart from that, not only for your like your FPGA based implementation, but if you are doing like FPGA based prototyping, right, so the prototyping jobs are also available. Apart from that, FPGA can be used for your like emulations. So emulation jobs are also available in India. Just to classify your answer, so if you are looking for any job opportunities like here in India, so we have design verifications, then prototyping, and then emulations. So these are the broad areas where mostly jobs are available in the VLS and was specifically in terms of FPGA field.
Okay, thank you, Nilesh. So we have our second question. What are the possible job roles for CS students, computer science students?
Yeah, as I said, like if you have seen in our slides, like the emerging technologies. Okay, so we learned about like the 5G technologies. Okay, then AI and ML. Okay, and the quantum computing. Okay, so this quantum computing and AI/ML, these are the two areas where like FPGA has been like extensively used, and that is going to decide the future of your FPGAs. So there I feel the computer science students can be much beneficial. Okay, they can contribute in a way like to generate we have a platform. Okay, for your FPGA based prototyping, but how to effectively make use of that platform, or how to write the code at the abstraction level, which is like C language or maybe C++ language, and then how this integration should happen, and how we can effectively use that integration will be the role for your CS based application students.
Okay, okay, thank you, Nilesh. So we have one last question. How can users get trained in Synopsys tools and students can get trained?
So as Tarun has explained, like we have this platform called as like SARA. Okay, it is Synopsys Academic and Research Alliance. Okay, so where we are partnering with lot of universities. We have a standard course set is available where we will be like delivering to students. Apart from that, we have tie up with this government scheme like C2S and PLI, where we will be providing the tool sets to the universities to try out, and the government is giving the projects to them. Apart from that, Synopsys can also help in like doing the faculty development program as well as the workshops for the universities. So that through that way or through that channel, the students can directly get trained from the Synopsys industry experts.
Okay, thank you, Nilesh. We have one more question. Can we
Yes.
synthesize code based on simulation method?
Pardon, can you synthesize?
Can we synthesize code based on simulation method?
No, this question is not quite clear to me.
Okay, okay.
You
Aniket,
wanted to
what we
do
can do is, can you
simulation
just allow the participant to ask the question directly so that it is interactive?
That is not actually available to us, but
no,
we
no.
have one
So
more question.
you mean to say like you wanted to means you want the same RTL which you have used for doing simulation, the same RTL you want to do you want to use for synthesis? Is it that question?
Online board synthesis.
Online board
You can
synthesis.
request the participant, whoever has written it, can you just mention them so that they can refine the question?
Okay, okay. So we request the guest to please reframe the question. By that time, we can move to the next question. So,
Yeah.
how FPGA implementation can be done in image processing area?
Yeah. So for image processing area, see, FPGA has been like the biggest advantage is like the reconfigurability and the high speed transmission. Okay, it can be used for your uh, uh, parallel processing, and it can be used for your like high speed data transmission. Okay, so FPGAs like can be extensively used to implement your image reading and image processing applications. Okay, so just to give you one example, if I take the example of like some image processing example in your FPGAs, right? So we will capture some image from your camera. Okay, and either we can do two things. Okay, we can post process that image, and we can save it for your later observations, or we have to do something to take some decisions. Okay, so for that thing, for taking some decisions, we need a very quick processing. Okay, so in FPGA based implementation, we have lot of IPs are available, like your MIPI IP, codec IP, which will help you to capture that image, process that image, and then take some decision and then display that image, or maybe do something related to that image. So that way the FPGA will be the best suitable, like it has different peripheral IPs will be available. The data transmission will be very fast. So in that scenario, FPGA would be very much uh, suitable for doing your image processing. And that can be suitable for your the automotive thing. It can be suitable for your medical thing. So based on this this platform, you can implement it on anywhere, like which application you want.
Okay, okay. Thank you, Nilesh. We have one more question. So the
Yeah.
question is how to apply in a SARA scheme. Any criteria is required for colleges?
I think for that reason, maybe I would like if anyone is interested to get enrolled for the SARA team, maybe you can get their email, and then maybe we can divert it through our SARA team, and then SARA team can get in touch with the colleges. Or maybe you can just go to Synopsys website, and there you will find the SARA, the Synopsys Academic and Research Alliance. That page you can find. And
Or
then
you
you can
can
get
send your
registered over there, or
inquiries
you
to
can send your
me.
query. Yeah, Tarun will
We
be the
will,
best person to get you
yes,
enrolled.
yeah, please. So you can, for any inquiries, you can contact me. You can write a mail to tarun.blr@EDS Technologies, or you can note down my number, the first one, 9945577397. That is my number. So I'll be reach out and over the WhatsApp as well. So you can send your queries to us. If you have any queries missed, you can write it to us. We are there to get it addressed through Synopsys, and we will be sending back to you over an email.
Okay.
Aniket, are there any more questions?
No, we don't have more questions. So we are at the end of our
Okay.
session. So now
Okay.
I would like to thanks Mr. Nilesh for delivering a very insightful webinar today. I'm very confident it was very helpful for our audience today. I also would like to thanks our audience for taking their time out and joining this session. So if you like Tharun mentioned, if you have any queries related to the subject matter, you can please reach out to us. On the screen you can see the details. Uh, so please, we request you to do keep an eye on our upcoming seminars and webinars, and you can follow us on our social media platform. So that's it. Thank you, audience, and thank you, panelists, for the wonderful discussion.
Thanks, Aniket. Thank you,
Yeah.
Nilesh, for accepting our request and providing this short and very good, insightful webinar. So thank you so much once again. And I thank all the professors who have taken your valuable time and joined this session. I hope it was useful. So we request you to submit the feedback. I think Aniket will be sending the feedback, right, Aniket?
Yes, we will be sharing through mail actually.
Yeah. Please share your feedback, and if you have any queries or any concerns, please write it to us. We are there to support you. Thank you so much.
Thank you.
Thanks,
Thank you.
Aniket.
Thank you.
Thanks, Nilesh. Bye.